Okay, so we're going to calculate density, and then you guys have your equation for density, right? Mass over volume, good. So mass over volume is density. What was the quantity for mass? 0.09 grams. What was the quantity for volume? Where did you get that?
I multiplied the length, the width, and then I converted the 0.27 millimeters to centimeters, and then I times it.
Right. So our volume, we're going to have to go length times width times height to get our volume. So our length, 5 centimeters, is that correct? 5 centimeters for the length. And then our width was that 0.3 centimeters? And then the height, that was the thickness. That was in millimeters, 0.27 millimeters. But we're trying to get the volume, so that would have to be centimeters cubed. We have centimeters times millimeters. That's not going to give you centimeters cubed. So what did you have to do again? You converted, yep. You convert that thickness to centimeters. And there's a bunch of different ways to do it, but we need to learn dimensional analysis, so I'm going to show you the dimensional analysis way to do it. If we start off with millimeters, we need to use a conversion factor to convert from millimeters to centimeters. So a conversion factor, it's when you have two quantities that are equal. So how many millimeters are equal to 1 centimeter? Yep. How many millimeters are equal to 1 centimeter? Right. So 10 millimeters, that's equal to 1 centimeter. So this is a conversion factor. 10 millimeters are equal to 1 centimeter. We can arrange that conversion factor in a way that is like a fraction, and you can arrange it to help you convert millimeters to centimeters. And the way you do that is to have the unit that you start with, or the unit that's going to be on top. We want to arrange that with that unit on the bottom. So if you have millimeters on top, you put millimeters on bottom so they cancel out. What are we looking for again? Centimeters, right? Look at your unit that's left over there. Centimeters. So since we have centimeters left over, that's verification that we did this correct. So now what you got to do, 0.27 divided by 10, that's how you get your length. 0.027 centimeters. So now we have our length, our width, our height. We just need to plug in those numbers and calculate. So 5 centimeters times 0.3 centimeters times 0.027 centimeters. And what do you end up with? Has anybody calculated this one yet? Tyler, what did you say you ended up getting when you calculated that? Yes, sir.
0.0405.
Yep. 0.0405 centimeters. 1, 2, 3. So centimeters times centimeters times centimeters gives you centimeters cubed. That's how you do it. But we have one more thing that we're forgetting about here, and that's significant figures. So our answer, you have 1, 2, 3 significant figures. But the numbers that we calculated here, 2 sig figs, 1 sig fig, 1 sig fig. It's like golf, the lowest number of significant figures wins. So 1 sig fig wins. We've got to make that we got to round that so that you only have one significant figure. So 0.04 centimeters cubed is the correct volume, but we still need to convert that over to milliliters, right? You remember on the back page, do y'all remember how many, do you remember that conversion factor for centimeters cubed to milliliters? You weren't here yesterday, so you don't have that, but this is what it looks like. 1 centimeter cubed is equal to 1 milliliter. So if we know that it's, what was it, 0.04 milliliters, or 0.04 centimeters cubed, so if we know that a milliliter is the same thing as centimeters cubed, then we could just say, okay, 0.04 milliliters is our volume. And then we just plug that in. 0.04 milliliters. And now we just need to calculate 0.09 divided by 0.04. What do you end up with? .25 grams per milliliter. But if you look at your sig figs here, you've got 1 sig fig, 1 sig fig. So we need to round this so that you end up with one significant figure. So it will end up 2 grams per milliliter.